Hello students, welcome back to another geometry video. You know what to do, pause the video, try this problem in your notes, and then unpause it to do it with me. We are told that the endpoints of AB are this point and this point. Find the coordinates of the midpoint, then find the distance between the 2 points. Okay. So we want the midpoint and we want distance. So I'm going to do midpoint over here and distance over here. Remember that the midpoint is the average of the x's, comma, the average of the y's. So what I'm going to do is I'm going to take the x's, 1 plus 7 divided by 2, and the y's, 2 plus 8 divided by 2. And 1 plus 7 is 8. 8 divided by 2 is 4. 2 plus 8 is 10, and 10 divided by 2 is 5. So there is the midpoint of this segment. Beautiful. Now the distance. We talked about two different methods that you can use to find the distance between 2 points. I like the second one, so I'm going to do the second one. I have x and y. A is 1, 2, and b is 7, 8. So now I have 1 minus 7 is negative 6. 2 minus 8 is also negative 6. And now I'm going to take negative 6 squared plus negative 6 squared and take the square root of all of it. So I get 36 plus 36 underneath the square root. Whoopsie, that went a little too far, huh? And then 36 plus 36 is 72. And the square root of 72, you know, I can't say that I know what that is. Now your teacher might want you to leave it like this, or they might want you to say that the square root of 72 is approximately 8.48 or 8.5. In my classroom, either of those will work. For now, I don't care if you use the square root or if you use the decimal, but do what your teacher says. So, there we go. There is the distance, and we already found the midpoint. So, we are ready to rock and roll with section 1.4. So, section 1.4 is about perimeter and area in the coordinate plane. Remember, the coordinate plane just means that we're talking about the x-axis and the y-axis, so don't freak out that coordinate plane is some fancy word. So our learning target is you know what the different polygons are and how to find their perimeter and area. Next, you can, or your success criteria is that you can classify polygons and find the perimeter and area of specific polygons. So, first, what is a polygon? We said that word quite a bit, but what is a polygon? In geometry, a figure that lies in a plane is called a plane figure. So it's all in one plane. It's like on a sheet of paper. It's not three-dimensional. It's two-dimensional. A polygon is a closed plane figure. What closed means is you can't have a shape like this. This has like an open side I could pour water into. You don't want to pour water into your polygons. Your polygons need to be closed, so all the sides are connected. You can't have two sides that just aren't connected. So it needs to be closed, and it must be formed by 3 or more line segments, which we call sides. So you have to have 3 because I can't make a shape with only 2 sides. In non-Euclidean geometry, which you will learn about in college if you do more geometry and more math in college, in non-Euclidean geometry there is a 2-sided shape, and actually in non-Euclidean geometry those are straight lines, and it's called a lune. That's separate. If you want to learn about lunes in non-Euclidean geometry, keep studying math. But In Euclidean geometry, which is the geometry that you learn in high school, that's the geometry we're talking about right now, it's not possible to make a shape with two sides. So I have to have at least 3 sides. I have to have a triangle, a quadrilateral, or, you know, more sides. 5 sides or something like that. Must have 3 sides. Each side intersects exactly 2 sides at one vertex. What that means is this corner here, where the 2 sides intersect or where they meet, this corner is called a vertex. So, I'd like you to put this picture in your notes. You don't have to put all these words, that's a lot of words, but this picture explains what a side is, it gives you an example of a polygon, and it shows you what a vertex is. So I would like this picture in your notes, please. So, the vertexes are the corners here. Each of these is a vertex. We call them plural. Vertex is vertices, plural. So you don't say vertexes, you say vertices. Okay. No 2 sides can be collinear. Otherwise, that's like if I have a 5-sided shape, but the 5th side, instead of being a 5th side, the 5th side is like, that's the 4th side, and that's the 5th side. Like, it's all one line. That just counts as 1 side. It doesn't count as 2. So your sides cannot be collinear. Okay. And you can name a polygon by listing the vertices, plural of vertex, in consecutive order. So this polygon, you'll see it's named polygon ABCDE because we start with A and then we just go around in a circle. So we name it A, B, C, D, E. You could also name it A, E, D, C, B, as long as you go around in a circle. Doesn't matter. We could have started with D. We could have named it D, E, A, B, C. I think you get the point, though. Take one point in your polygon and go around in a circle. Now you have named that polygon. Ta-da. Okay. So now that you know what a polygon is, we're going to learn a little bit more about them. So here, on the left, right here, is the names of the most common polygons. So a 3-sided polygon is a triangle, 4-sided is a quadrilateral, 5 is a pentagon, because penta means 5, hexagon is 6, heptagon is 7, and so on and so forth. Now, you need to know the difference between convex polygons and concave polygons. Excuse me. So, a polygon is convex when no line that contains a side of the polygon contains a point in the interior of the polygon. Very complicated. That's what this picture shows, is that if you continue this side right here, if you continue that line, part of that line is inside of the polygon. Over here, none of these lines are ever inside of the polygon. They're only on the outside. They're only on the border. If that doesn't make any sense, that's okay. Concave means that it has a dent in it, basically. It's got a dent facing into the polygon. It's got a little cave. That's how I think about it. So here is your fancy definition of what convex means. A polygon that isn't convex is concave, and then yeah. But concave is just anything that has a little dent or a little cave in it. That's how I think about it. One thing I almost forgot to mention is you can also name a polygon using the term n-gon, where n is the number of sides. So a 14-gon is a polygon with 14 sides. So if you ever forget what a 9-sided figure is, you're like, nonagon? I don't remember what a nonagon is. That's okay, you can just call it a 9-gon. And we mathematicians will know what you're talking about. Okay. Awesome. Now we know more about polygons. Let's classify them. So, we need to classify it by the number of sides. So that's what this is over here. Classify it by the number of sides. Based on the number of sides, what type of polygon is it? And we need to tell whether it's convex or concave. So that's where these come into play. Okay, so first, the number of sides. We know how to count. 1, 2, 3, 4 sides. So this is a quadrilateral. If you call it a fourgon, that is also an accurate statement. I would give you credit on a test for calling it that, but you also want to know the word quadrilateral. We're going to talk about quadrilaterals so much in Chapter 7. Okay, so that's the number of sides. Is it convex or concave? Well, I see a pretty big dent in this shape, so it is definitely concave, because it has a cave-like shape to it. Also, another way you can think about it is if I draw a line through this side, through this side, I have, that line is going through the shape. That's another way that we know it's concave. Okay, all right, next, so that's part A. Part A is done. We said the number of sides, and we said whether it was concave or convex. So we are done with part A. Now on to part B. Number of sides, 1, 2, 3, 4, 5, 6. 6 sides means that this is a hexagon. If you play Rocket League, Drop Shot, you're familiar with hexagons. Okay, and otherwise you can call it a sixgon. It's the same thing. Now, is this convex or concave? I don't see any dents. All of the corners are facing out of the shape. There's nothing pointing inwards towards the middle of the shape. And if I draw a line through each side, those lines will never cut into the middle of the shape. So, this is convex. If it has dents, if it has a cave, it's concave. If it doesn't have any caves, it is not concave, it is convex. So there you go. We found the number of sides, and we said if it was convex or concave. So we are done with part B. Check and make sure we were correct. Quadrilateral, concave, hexagon, convex. Boom! We were right. Okay. Now, that was our polygon section of the lesson. Now we are going to talk about perimeter and area in the coordinate plane. So, you remember your good old perimeter and area of a triangle, square, and rectangle. I've put them here to remind you of them if you forgot. Area of a triangle, 1/2 base times height. Area of a square is the side squared. Area, and that's why we call them squares. Or maybe that's why we call squaring square. Ooh, you might never know. Rectangle, base times height, or length times width, same thing. And then perimeters, for a triangle, you just add up the sides. For a square, you also add up the sides, but it's the same side you're adding every time. So instead of s plus s plus s plus s, we can just say 4s. And the perimeter of a rectangle is 2 of the wide sides times 2 of the long sides. So that's a quick refresher on the perimeter and area of these types of shapes. And these are the only shapes that we're going to be finding the perimeter and area of in the coordinate plane. We're not going to be doing other polygons yet. That will be chapter 11 that we talk about that, because it's a little bit harder than these basic shapes we've been talking about. So you can use the formulas given below and the distance formula, which we learned about in last video, to find the perimeters and areas of polygons in the coordinate plane. So we're going to use these formulas as well as the distance formula to find perimeter and area. Don't forget that perimeter has linear units, such as feet or meters. When they say linear, they mean one-dimensional. Remember, because lines are one-dimensional. And when they say that area has square units, it's because it is two-dimensional. Think of it as a plane where you can go up, down, left, right. And that's why we have feet squared, because we're in 2 dimensions. Okay, alrighty. Moving on to an example. First, we're going to find perimeter in the coordinate plane, and then we're going to find area in the coordinate plane. So, first, find the perimeter of triangle ABC, and that's how you read this, is triangle ABC, with these vertices. Very first thing I'm going to do is picture. Picture, 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 picture. And I'll show you why a picture is so helpful after we draw it. So A is -2, 3. B is 3, -3. And C is -2, -3. Now let's connect those dots. Perfectly straight line segments, of course. Okay, so now we want to find the perimeter of this triangle. Remember that perimeter is just the distance around a figure. So if I want the distance of, or excuse me, the perimeter of this triangle, I just need to know how long this side is, how long this side is, and how long that side is. And then I just add them all together. X plus Y plus Z, that's the perimeter. If I walked around this triangle, how many feet would I have to walk all the way around this triangle? That's what perimeter is. So what we need to do is we need to find each of these sides. We need to find AC, we need to find BC, and we need to find AB, and then we're just going to add them all together. And we have our perimeter. Here's why drawing a picture is helpful. We could just use the distance formula and find the distance between all three of these points. That will work if you find the distance between the three of them. That will work. But there's an easier way. Remember the ruler postulate, that if we had a perfectly vertical or a perfectly horizontal line, we don't need the distance formula. We can just use the ruler postulate. The distance formula is for non-vertical or horizontal. It's like slanted lines that we use the distance formula for. So let's color code. I'm a big color coder. You'll find that out soon enough. So AC. In order to find the distance between A and C, I just need, remember, the absolute value of one coordinate minus the other. So this is AC. And remember, the coordinate, it's like I'm using the vertical ruler. Because this segment is vertical, I'm going to use the vertical ruler, which is the y-axis. So here, my coordinate of A is 3. So that's my first coordinate that I'll be subtracting in the absolute value. And next, down here at the bottom, we have -3 is the coordinate of C. So -3. Okay, so now minus a negative makes a positive, and we have the absolute value of 6, which is 6. So we didn't have to do the distance formulas. So complicated, right? Compared to this. This is so much less complicated. So I would much rather use the ruler postulate over the distance formula anytime I get. Any chance I get. Okay, next, that was AC. Now let's look at the other horizontal side. Let's look at BC. So BC, again, because this line is horizontal, we're going to use the horizontal ruler, which is the x-axis. And C is at -2, so the absolute value of -2 minus B is at 3. So -2 minus 3 is -5. Absolute value of -5 is +5. Cool. So this side is 5 units long. This side is 6 units long. And now, let's do this last side over here, AB. Now I can't use the ruler postulate anymore. Now I have to use the distance formula. So in the entry task, we did the table method. Now I'll use the other method. I'll do the square root of x2 minus x1 squared plus y2 minus y1 squared and the square root of all of that. Now I'll plug in some numbers. A and B are the points that make up this slanted segment. So I have x1, y1, x2, y2. So x2 is 3 minus x1 is -2 squared, plus y2 is -3 minus y1 is 3 squared, and the square root of all of that. Beautiful. 3 minus -2, so this is 5 squared plus -6 squared, and the square root of all of that. Ooh, 5 squared is 25, plus -6 squared is 36. So we have the square root of 61. I don't know what the square root of 61 is, so I will find a approximate answer of 7.8. 7.81, but we'll just round. Okay! Beautiful. Am I done? In order to know if we're done, we have to check. What was the question asking? It said to find the perimeter. Have we found the perimeter? I don't see it. I don't see the perimeter. Remember, the perimeter is when we add up the red, the yellow, and the green. When we add up all of these sides, that's where we get the perimeter. So, I need to add up each of these numbers. So we will go a different color again. We will go 6 plus 5 plus 7.8 is approximately, because remember, the 7.8 was approximate, so now everything is approximate. Okay, so 6 plus 5 is 11, and 11 plus 7.8 is approximately 18.8 units. But they didn't give us units. 18.8 units. Beautiful. Wonderful. Okay, now we're done because we found the perimeter. So let's check our answer. Side AB, 7.81. Ruler postulate, 5, 6, 18.81. Yes. Beautiful. We did it. Okay. Example 3, finding area in the coordinate plane. Okay. So notice that both of these examples are of triangles. You might have homework that involves rectangles or squares, but triangles are a little bit harder than rectangles or squares. Rectangles and squares, it's easy to see. Well, one, you don't need the distance formula. You can just use the ruler postulate every time. And two, it's very easy to see what the height is and what the base is. So that's why I'm showing you examples of the triangle, because the triangle might be harder to figure out what the base, what the height is, and things like that. So, find the area of triangle DEF with these vertices. So, of course, we're going to draw a picture. D is at 1, 3. E is at 4, -3. And F is at -4, -3. And we'll connect all of those dots. Okay, beautiful. So remember, we're trying to find the area of this triangle. I don't need to figure out what all the sides are. The area of a triangle is equal to 1/2 times the base of the triangle times the height of the triangle. So I just need to figure out what the base and the height are. The base, I can just use this right here as my base. So, different color, I need to find this length right here. I need to find the length of FE, which is, I can use the ruler postulate since this is a horizontal line. The coordinate of F is -4, and the coordinate of E is +4. Negative 4 minus 4 is negative 8, which means that our base is 8, because the absolute value of negative 8 is positive 8. Great, so our base is 8. Now, what is our height? So the height, anytime we talk about height, it has to be perpendicular to the base. I need to go from the very top of my triangle, which is D, and I need to drop down perfectly perpendicular. Because when you think of base and height, I think of the wall and the floor, right? Those are perfect 90 degrees between the wall and the floor. If that is not, if the wall is kind of slanted, that's not truly the height of the room. The height of the room goes from the floor all the way to the ceiling. Doesn't matter if you have slanted ceilings or not. So we go from the top all the way down to the bottom. And so now, and in fact, let's do this in a different color. Now I need to know the length of this. I need to know the length of this segment. So I'm going to call this, what, A, B, C, D, E, F, G. Let's call this point G. Now starting from the top and going straight down, I need to know what the length of DG is. Now I need to know what the length of DG is. So because this line is vertical, I need to use my vertical ruler, which is the y-axis, and D is at 3, and 3 minus, G is at negative 3. Minus a negative is a positive. So we have the absolute value of 6, which is positive 6, and now this is our height. Because it is straight up and down, perpendicular to the base of our triangle, this is our height. So 6 is our height. And now, we'll go back to purple. I know that the area is equal to 1/2 the base, 8, times the height, 6. There you go. 8 times 6 is 48, so this is 1/2 of 48, which is 24. Units squared. Square units. And it is important. I know sometimes we've just forgotten about units when they don't give us units, but when you're talking about perimeter versus area, it's important to make the distinction. Perimeter is just units, but area is units squared, because area is 2-dimensional and perimeter is 1-dimensional. Perimeter is if I walk around this triangle, how far have I walked? Area is if I paint this triangle, how much paint do I need to cover the whole triangle? So, area is 2-dimensional, that's why we have units squared, and perimeter is 1-dimensional, which is why we just have units. No units squared. Okay, awesome. That was example 3. Let's make sure that we were correct. We most certainly were. 8, 24, 24 square units. Beautiful. All right, if you have questions, make sure to ask them. Talk to your teacher, phone a friend, email me, whatever you want. Get your questions answered. Of course, as usual, these are the practice problems you can do to practice the skills you have learned in this video. So, these might be different than the problems your teacher assigns, so make sure to check that. And of course, we always end our videos with a launch. Today's launch comes from William James, and he says, "Act as if what you do makes a difference." It does. So what this means is everything you do makes a difference. It can make a positive difference, or it can make a negative difference. So, be very intentional about what you say. Don't just think, oh, it doesn't matter. I can tell Becky your hair looks stupid and it doesn't matter. Like, no, that makes a difference. What if Becky hears you? She could be crushed. Why the heck are you making fun of Becky's hair? Becky can have her hair however she wants. Also, even if Becky doesn't hear you, You're saying that to somebody else, and now somebody else is, I mean, they could say, hey, don't talk about Becky like that. But peer pressure, they're probably going to say, yeah, I don't like it either. And now you have a group of people talking about how Becky's hair looks? Why? Why you want to just be rude to Becky? That doesn't make sense. We need to be kind. We need to be kind to everybody. So everything you do makes a difference, and it can either make a positive difference or a negative difference. That is up to you. So try to make a positive difference instead of making a negative difference. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching.